in example 4, not only are we going to compute an average rate of change, but we're also going to try to make sense of it, okay? So in example 4, the function that we are going to be working with is h of x is equal to x squared minus 2x. That is the function we will work with through this entire example, okay? This example takes up the whole page, okay? So you can scroll and see, okay? All right, so let's get with it. All right, in part A, knowing the function we're working with, okay, it says find the average rate of change of the function h from x equals -1 to x equals 4. Okay, so remember what I told you when I introduced you to the formula for average rate of change. When you compute an average rate of change, not only do you have to have a function, but you also have to be given two x values that you're looking at. Okay, so if you look at this function, okay, we haven't graphed it out. We're actually going to sketch a graph of it in part B, but this is a polynomial. Okay, its domain is all real numbers. So its graph is defined over the entire x-axis. We're not interested in the entire graph. We're only interested in the portion of the graph between these two x values. Okay, so between x equals -1 and x equals 4. Okay. All right, I told you the easiest interpretation of average rate of change. Think of it as the slope formula. Okay, so we need to compute y2 minus y1 over x2 minus x1. Okay, so we need to figure that out. Okay, so let's start. Our first x value is -1. That's the one I'm going to call x1. Okay, well, we need to get y1. Okay, how do you get y1? Well, you plug x1, which is -1, into the function. Okay, so here we go. Y1 is going to be h of -1. That's going to be -1 squared minus 2 times -1. Okay, we just plugged in -1 for x into our function. Okay, let's simplify. Okay, the -1 is squared. So the negative is squared, as is the 1. So -1 times -1 is +1. And then negative times negative will give us +2. Okay, so this is going to be 3. Okay, this produces an ordered pair. If x1 is -1, then y1 is going to be 3. Okay, so here you go. I'm going to go ahead and label this. This is x1, y1. All right, so we need the other ordered pair. Okay, we're going to get it in the same way. The other x value we've been given is x2, which is 4. So to get its corresponding y value, we need to plug 4 into the function. Okay, so y2 is going to be h of 4, which is going to be 4 squared minus 2 times 4. That's going to be 16 minus 8, which is 8. Okay, so this gives us another ordered pair. Okay, so this time, if x is 4, then the output is 8. Okay, so this is going to be our x2 and our y2. Okay, first point, second point. Okay, so now I've run out of room. Okay, I've got to compute the average rate of change, which is just the slope formula. Okay, so I'm going to come back over here. So I'm going to work this way. Okay, so if I just follow the formula, I need to do y2 minus y1, and I've already labeled my points. So this is going to be 8 minus 3 over x2 minus x1. Okay, so I'm going to write those down. x2 is 4 and x1 is -1. Okay, so this is going to be careful here. This is x2, which is 4. You're subtracting x1. x1 is -1. Okay, when you're doing average rate of change, or if you're doing slope, you've got to be careful if you're subtracting a negative. Okay, you've got to watch out for that. Okay, so if we simplify this, the numerator is going to be 8 minus 3, which is 5. The bottom is going to be 4 minus a minus becomes plus a positive. So that's going to be 5. Okay, so we get that the average rate of change is 1. Okay, so that is the answer. Okay, average rate of change is a slope. Okay, so I usually abbreviate it AROC. The average rate of change here is 1. Okay, not a very interesting answer, but that's what it is. Okay, that is how you compute an average rate of change. You are given two x values. You take each x value, you plug it into the function to get the corresponding y value. Okay, that's going to give you two ordered pairs, x1, y1, x2, y2, and then you apply the slope formula, y2 minus y1 over x2 minus x1. And that gives you the average rate of change. All right, so that's how you compute an average rate of change, but now we need to talk about what it actually means. Okay, so we will do that in parts B and C. Okay, so if we scoot down here, in part B, it says draw the graph of H and the secant line containing -1, H of -1, and 4, H of -4 on the same grid. A secant line of a curve is a curve. A secant line of a curve is a line that intersects the curve in 2 points. Okay, so there's a lot going on there. Okay, let's just start with the first part. It says draw the graph of H. Okay, so we've got a grid here, and we're going to go back and grab our original function. H of x is equal to x squared minus 2x, and we're going to graph it. Okay, remember, it's a polynomial, so the domain is all real numbers. So if we make a table of values, that's what we're going to do to graph this out. We can really pick whatever we want for x, but we've got to be smart here. So let me go ahead and set up the table. Okay, so we're going to graph this by hand. We're going to make a table of values. We are going to plug in, we get to choose the x values. Okay, and then to get the corresponding y values, we're going to plug into x squared minus, let's see, what is it here? 2x. Okay, here we go. Okay, so like I said, the domain is all real numbers, so that means you can plug in any x value that you want. There's no conditions on x that have to be met. But remember, we're computing the average rate of change between x equals -1 and x equals 4. So that's the portion of the curve that we want to look between. Okay, so we're going to plug in -1, 0, 1, 2, 3, and 4. Okay, you may not need all of these, but you definitely want to put -1 and definitely 4. I picked the other x values just so we get a really good picture of what's going on in between. Okay, so remember, you can think of this function as x times x minus 2x. Okay, we're going to plug each one in to get the y value. Okay, if we plug in -1, this is going to be -1 times -1 minus 2 times -1. This is going to be 1 plus 2, which gives you 3. Okay, and so then that's going to give us an ordered pair to plot. Okay, so this graph will go through the point x is -1, the y value is 3. Okay, so we can go ahead and plot that point right here on the graph. And then we just keep doing this. Okay, so then if x is 0, the y value is going to be 0 times 0 minus 2 times 0. That's just going to be 0. So the corresponding point here is going to be x equals 0, y equals 0, so the origin. Okay, so the graph will go through the origin here. All right, now we plug in y equals 1. So plug it into the formula. We're going to get 1 times 1 minus 2 times 1. That's going to be 1 minus 2, which is -1. So an input of 1 gives us an output of -1. So we're going to plot 1, -1. That's right here. And then we're going to plug in 2. So we're going to get 2 times 2 minus 2 times 2. That's going to give us 4 minus 4, which is 0. So an input of 2 gives you a y value of 0. So this curve goes through 2, 0 right here. All right, almost done. Let's plug in x equals 3. We're going to get 3 times 3 minus 2 times 3. That's going to be 9 minus 6, which is 3. So the curve goes through 3, 3. That point is right here. And then lastly, x equals 4. That's the y value will be 4 times 4 minus 2 times 4. So that's going to be 16 minus 8, which is 8. So an input of 4 gives us an output of 8. So our last point to plot is 4, 8. Okay, so there we go. Okay. All right, so if you noticed, The function is x squared minus 2x. It has the format ax squared plus bx plus c. Okay, I've mentioned that to you before. That has a U shape to it. Okay, and you can see the points fall along the U shape. Okay, so, I'm going to keep going. You don't have to, but the graph, if I extended it, it's just going to go up like this forever. Okay, so this is the graph of h of x is equal to x squared minus 2x. All right, so that's the original curve. Okay, we need to talk about what the average rate of change between x equals -1 and x equals 4, what that means. Remember, the average rate of change between those two x values is +1 when we computed it. Okay. All right, so the directions in B were kind of crazy, so let's go back through them. We already drew the graph of H, and now it tells you to draw the secant line. Okay, a secant line is a line that intersects your curve in 2 points. So we're about to put a line on here that intersects the parabola in 2 places, and that's going to be the secant line. Okay, now it tells you in the directions the secant line has to go through these 2 points. Okay, well, they look crazy. So let's interpret these. Okay, let's come out here. What in the world does this mean? Okay, -1, h of -1. Okay, and then also 4 in h of 4. Okay, these are ordered pairs. Okay, so the way you translate this is that the x value is -1. The crazy part is h of -1. Okay, remember, h of -1 is the y value when you plug -1 into the function. Okay, we already computed that. Okay, h of -1 is 3. Okay, so this was a fancy way of talking about the point -1, 3, which is this point right here on the graph. Okay, I guess I'll put it maybe in red so you can see it better. That's this point. Okay, I think they do this because they don't even want to they don't want to give you anything. They don't even want to give you the y value. They wanted you to have to figure out the y value for yourself. Okay, so that's why it's kind of coded. Okay, so the other point that the secant line has to go through is 4h of 4. Okay, so again, the x value is 4. H of 4 is referring to the y value when the x value is 4. We computed it above. H of 4 is 8. Okay, so this is talking about the point 4,8. And on the graph, we already see that point. It's right here. Okay, so what you're supposed to do is draw a line between these 2 points. Okay, so let me do that. Okay, I'm just going to connect these 2 points with a line. The line has to go through both of the points. Okay, so hold on, let me try to get this like I want it. Okay, that works. Okay, so this red line is called the secant line. It is intersecting our parabola in these 2 points. Okay, so let's go back through the directions. We drew the graph of H, that's the blue parabola, and now we've drawn the secant line containing -1, 3, and I'll even label these points. This is -1, 3, and this is the point 4, 8. Okay, that secant line is a line that intersects the parabola in 2 points. Okay, all right, so there's a statement below here, okay, that is going to explain what the average rate of change is. Okay, remember in part A, we had this function, the parabola, h of x is equal to x squared minus 2x. We examined the part of this graph between x equals -1 and x equals 4. We computed the average rate of change between those two x values, and we came up with a value of 1. Okay, so this statement is going to interpret that for us. It says, note that the average rate of change of a function from a to b equals the slope of the secant line containing the 2 points, a, f of a, and b, f of b. Okay, so it's getting mathy on us again. Okay, but what you need to realize, the average rate of change here, this is what the statement is saying, the average rate of change that we computed was 1. This is 1 is the slope of the secant line. And I know we haven't done lines yet, but I'm sure you've done lines in the past. Slope is rise over run. Okay, so look at this. Okay, I'm going to start at negative 1, 3. Okay, if I go up 1 over 1, 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 I get to the other point. Okay, that proves, because my rise is positive 1 and my run is positive 1, every time I do this, the slope of this red line is 1. Okay, slope is usually designated with the variable m. Okay, the slope of this secant line is 1. Okay, that's what the average rate of change is. Okay, so another way you want to, and this is important, you want to equate these two. Average rate of change, whoops, average rate of change is synonymous with slope of the secant line. Okay, all right, that's big. Put a star by it. All right, in part C, it asks us to find an equation of the secant line containing these 2 points. Okay, again, translating these 2 points, we're talking about the red line that goes through negative 1, 3, and 4, 8. Okay, as soon as we finish this section, we will start on 2.2 lines. Okay, and we will learn how to write down the equation of a line. Okay, so this will give you kind of a heads up. The equation of a line has this format: y equals mx plus b. Okay, x and y are variables, and then m is the slope of the line, and b is the y-intercept. Okay, so what you need to do here, okay, we're going to have to basically say, we need to fill in the m and the b. Okay, so x and y will stay x and y. All right, so let's first deal with the slope. Okay, what's the slope of the red line? Well, it's the same thing as the average rate of change. We said that that is 1. Okay, so the slope here is 1. Okay, so we're going to have 1 times x plus, now we need to go read the y-intercept off the graph. The y-intercept, remember, since the slope is 1, you're going to go up 1 over 1. Okay, so the y-intercept is going to be positive 4. Okay, and that's it. Okay, we filled in the m and the b. If we simplify this, okay, the equation of the secant line is y equals x plus 4. Okay, so if we go back up here, this red line has an equation y equals x plus 4. Okay, all right, so this was a long example. Okay, again, you were shown how to compute an average rate of change of a function between two x values. Okay, and then in parts B and C, we try to interpret it. Okay, so if you graph out the original curve and you look at the 2 points on the curve associated with the given x values, the 2 x values you're interested in, and you draw a line through those 2 points on the graph, you end up with a secant line. The slope of the secant line is the same thing as the average rate of change.